Part 3 is a collaborative, data-driven construction administration software built for architects and engineers. With Part 3, you'll complete your administrative tasks faster than ever before. You'll streamline your submittals, RFIs, change documents, and field reports with automation and intelligence. Stop wasting time on tedious tasks. Schedule a free demo of this transformative automation tool today at part3.io/getstarted. That's part3.io/getstarted. Experience construction administration performance today with Part 3. Are you tired of dealing with generic IT providers that rely on you to be the expert? Ask yourself, does my IT provider understand the software tools that I'm using on a daily basis? If I'm on a deadline and lose access to my project files, is my IT provider available 24/7 to help me? Does my IT provider help me select and integrate new software? When you're focusing on problems like these, you're not working on your next big project. ArcIT is here to help. We focus on solving technology for architecture firms so that you can focus on doing your best work. Find us at getarchit.com. That's getarchit.com and click Work with Us.
My name is Mark R. LePage, and I'm joined by Patrick MacLeamy, FAIA, and former CEO of the international architecture firm HOK. This is buildSMART. After his time at HOK, Patrick, as he puts it, has been repurposed. Now, as the chairman of buildingSMART International, Patrick will outline a new strategy for the building industry and so much more. You'll find that there's a lesson in every episode. Okay, Patrick, last week you told us that communication was one of the big three building industry issues that we have to overcome. Communication in our industry, architecture, is by drawings, right? That's how we communicate. So how has that process of communication by drawings evolved over the years?
Well, it's an interesting story, and communication by drawings is as old as the building art. As far back as we can tell, people used crude drawings or diagrams to decide what they were going to build. And usually it was in the shape of something like a crude floor plan. Drawing on paper didn't occur until paper got invented. So how did they do it before? Well, they actually drew lines in the dirt for a while. What I found fascinating when I studied the medieval cathedrals in Europe is that the master masons, who were the designers of cathedrals, would actually pour a bed of plaster on the ground. And as it was drying, they would incise lines on it, and they would lay out a floor plan of a cathedral using their crude tools. They had a straight edge, compass, something to measure with, and so on. And after the plaster was dry, they would tilt it up on the wall of the master mason's work shed, and they would use dividers. And if it was one divider width between one column and the next, they would scale it up. They would go out to the job site. They would use those dividers back and forth, and count out 20 spaces of that same divider so that the building ended up 20 times larger, or whatever the scale was, than the drawing that was on that plaster. I just found that fascinating, that these builders were able to do these magnificent buildings with a kind of a crude sketch on plaster. Just amazing. They also did detailed drawings with chalk on the stones. And as the young masons would begin to shape that, the master mason, of course, the chalk would get washed off, and they would come back and remeasure and remark. And that was the equivalent, really, of what we call today shop drawings, the detailed drawings that people would use to build in a shop someplace of a piece of a building before it was actually brought to the job site. So drawings have been our communication art for centuries, and it worked pretty well. When paper got invented, people began to do ink on paper. It became an art in itself, how you describe. Think about it, Mark. Buildings are in three dimensions, right? They have length, they have width, and of course they have height. So we had to invent a system to describe a three-dimensional building on two-dimensional paper. We started with floor plans. Floor plan is a view looking from the top, from the sky, if you will, with the roof removed, so you can see how all the walls are laid out and so on. And elevations are drawings that show the sides of the buildings, what it's going to look like when it's finished. And cross sections are as if you took a big knife and you cut through your building so you could see how the pieces fit together. And then lots of drawings after that were details, showing how the window fits into the wall or the special place where the post meets the beam as part of the structure and so on. And that worked very well for centuries. It worked because buildings were simple. The great cathedrals of Europe were basically stone. And yes, there were other trades involved. Masons made the openings in the walls for the windows, and the glassmakers filled them in with beautiful stained glass. There were carpenters involved. Carpenters built the big doors that you enter when you go through a cathedral, and they built the roofs over the top of the vaulted arches. And there were other metal workers that built the roof materials, usually lead, to keep the rain out. But the buildings were simple. There were 3 or 4 trades, and the master mason was the equivalent of the architect. They were the ones in charge of what it was going to look like. And there's an analogy, Mark, of architecture is like music. The architect has this wonderful position of being able to compose the music or to design the building, and then, like an orchestra conductor, conduct the various parts and pieces of the orchestra, write the music for each piece. The oboes get their piece of music, and the clarinets get theirs, and the violins, the drums, and the orchestra leader, the conductor, is the architect. And the architect has everybody's music in front of him or her and conducts by hand gestures, telling each group when to start, keeping things on the beat so that the music is beautiful and harmonious. That's the architect's job, is to not only create that building, but to be like the orchestra leader and coordinate harmoniously all the parts and pieces. And as buildings have become more complex, Mark, that's the challenge that we're facing. Imagine this. You have an orchestra maybe of 100 people. Well, what if you have to add, because we have new inventions in our building world, we have now a mechanical system that we didn't have in the cathedral days, and an electrical system and a low voltage system. And we have air conditioning, and we have code compliance, and on and on and on. Now our orchestra is 1,000 people, 1,500, maybe it's 10,000, all the way through the supply chain. So it's difficult for people to even see the conductor. How can you continue to coordinate with drawings and hand gestures to such a large group? Well, fortunately, as technology has evolved, the computer was invented. And the computers are masterful at managing complexity. I like to say a computer is as dumb as a doorpost, but if you teach it how to do something, it will do it flawlessly. Add a column of numbers over and over and over again and always get the right answer. Far better, really, than humans at doing something as mundane as adding numbers together. So early computers mimicked what the architect did with drawings on paper. And at first, because of limitations on the computer, it was all two-dimensional. That was called computer-aided drafting or computer-aided design. So the computer was taught to mimic how we drew buildings by hand. That was an improvement, I suppose, in that we didn't have to erase. We could simply tell the computer to change a line and it would do it. I found it useful because my early drawings, I had to erase so many times. I erased myself through the paper. But the CAD drawings, Mark, were dumb. The computer didn't know what the lines were. They were just lines. So by the 90s, computers have gotten faster, and two-dimensional CAD began to be replaced by 3D CAD. Why was that useful? Well, it's always good if you can actually build a three-dimensional model of something in a computer so you can actually look at it from all angles and make sure that it's the design you want and that the pieces fit together. So 3D CAD was an improvement in that it allowed architects to visualize their finished building in much more complete ways.
In order to build smart, you need to operate intelligently. If you feel frustrated, Wrangling all your spreadsheets to get a clear view of where your projects stand today? Or you're tired of staring at poorly designed software that's just slowing you down? Monograph is here to help. Designed by architects for architects, the Monograph platform allows you to track your firm's time, projects, budgets, invoices, and payments all in real time. With their innovative visualization tool, MoneyGant, you can immediately see whether you're under or over budget. Need to easily adjust your team's time week to week? Their tool Resource allows you to reallocate your team's time and track its impact on your remaining budget. Visit monograph.com today to see why hundreds of architecture firms call Monograph a game changer.
So things got improved, but 3D CAD was still really dumb. There was no depth of understanding. And finally, after CAD came the big breakthrough from CAD to BIM, Building Information Modeling. Finally, computers got fast enough and software sophisticated enough that we could actually teach a computer to recognize the objects that we were putting into a building. If we told a computer this is a door, it would actually know that. Think about buildings, Mark. Buildings are made up of thousands of different parts and pieces, but all of them can be described in some way, usually by a little bit of geometry. A door is so high and so wide, and some words. It's a wood door, it's a stainless steel door, it's glass door, it's something. It's got a window in it, it doesn't. So the I of BIM, the information, the I became more and more and more important as we learned how to pack more information into the BIM model. I thought that geometry and coordination of geometry, how things fit together, was the essence, was the nirvana, but it was just the beginning. It's far more important that we coordinate things like how you insulate a wall so that you can keep the cold out in the winter and the heat out in the summer. And so you can have insulation value as one of the things that computers can be taught to understand, or how much sunlight comes through a window with what kind of glass you use. So if you're putting a window in a wall, a computer will be able to tell you how much heat gain you're going to have from the sun shining through that window at any day of the year. Those are marvelous things, Mark, and it's all because computers got smarter. So I think the information in BIM is by far the most important. Things like weight, volume, quantity, cost, energy efficiency, sustainability, and much, much more. So all these abstract concepts, if we can give precise information to the computer will remember it.
I mean, that's the answer, right? Is to have all that information in that model. It has everything we need. What's the big problem with BIM?
Well, it is the answer to have the computer manage all of that complexity. The problem is, Mark, the computer and the software that the computer uses reflects our industry. The software that we use as architects was designed for us by a software company someplace to our needs, to fit how an architect thinks and works and so on, and what information an architect needs to manipulate to design a building and so on. If we were engineers, we have different BIM software, often designed by a different company, specially designed for our needs. If I'm a structural engineer, it helps me determine the strength of a beam and whether it can span a certain distance between two columns. And if I'm an electrical engineer, I have wonderful BIM software now that allows me to lay out my electrical system and calculate my loads and automate many of the processes that I've been following and doing by hand. Well, here's what's wrong with it, Mark. Each software set is like a silo. The BIM software used by the engineers doesn't actually interact that well with the BIM software used by the architects. It's even a bigger gap between the design team and the contractor and the subcontractors. We do a good job of communicating within our own little profession, but we don't do a good job of communicating and coordinating with each other inside the industry because our industry, Mark, is fragmented. no one speaks for the entire building industry. No one says, hey, architect, you need to coordinate with this engineer and you need to exchange information between each other at 50 times during the design phase and 25 times during construction. And we need this specific information to be exchangeable by your computers, by your software. So we haven't achieved that level of automation that manufacturing has achieved, where the computers are doing a lot of the tedious work of coordination and leaving the people to be the thinking and creating parts of the process. If you watch an automobile getting assembled these days, a lot of it is being done by robots. Well, those robots are being driven by a computer program that really understands and has been taught how to assemble that automobile. We have nothing like that in our building industry. Little beginnings of it maybe, but nothing for the entire industry, because our entire industry is made up of parts and pieces.
So I'm starting to understand this, Patrick. I'm starting to understand that our built environment is built by these teams. There's these silos. There's architects, engineers, contractors, owners, all these different people who are involved in these buildings. Then we've developed this technology. The software is there. All of the pieces are there, but there's no way for us to get all of these segmented silos to communicate with one another. So what's the answer to this? Can't the software companies just get together and fix this?
Yes, well, I've had many discussions with software companies about that. And the software companies are eager and willing. They've begged us, please tell us what you want us to do, and we'll do it. We just have to have clear instructions from the industry. And so far, until this moment, you've only told us what your segment of the industry needs. So the issue that we have to overcome, Mark, is we have to reinvent our industry, at least as far as how information is exchanged. And we have to do that by creating something new. Mark, this is audacious. To create from scratch a global organization that would be charged with developing open standards for the industry, not just for the architects, not just for everybody, and have that organization do this process, this work by consensus, not by forcing everybody to use some technique or another. And that is a long and daunting task. And that's, of course, the story of buildingSMART, which we'll be getting to next week when we start talking about what we did about it. And I must say, I had no idea of the journey I was going to be embarking on when we began this process.
To continue the story, come back next week for the next episode of Build Smart.
Interest group grew to about 14 companies, and that was the original Alliance of Industry Partners. And I didn't have a lot of success convincing the management at Autodesk in terms of this being a good idea, truth be told. So the strategy I adopted, you might recall, is that I invited all those company representatives, very senior level, to come into the Executive Briefing Center in San Rafael. And I said, I will bring the CEO, Carol Bartz, into the room, and I need you all to tell Carol what it is that you are frustrated about and what it is you need.
Yes, I remember when she came in and sat down, and we kind of went around the table. Each one of us said this, more or less the same thing to Carol. She looked around at all of us and at you, and she said, well, okay, let's see where this goes.
Thank you for listening. Season 2 of Build Smart podcast has been made possible in part by buildingSMART International, the worldwide industry body driving the digital transformation of the world's built assets. Learn how buildingSMART International is impacting our world and how you might get involved at buildingsmart.org. This podcast is a Gable Media production and is produced by Demetrius Lynch Jr. Gable Media is the home of curated thought leadership for an audience dedicated to building a better world. You can listen in, subscribe, and find more content like this from our network partners at gablemedia.com. That's GABL media.com.